Don't run under the bus.
Okay, here we have two rectangular equations. Okay, they have x's and y's in them, and we're going to try to convert them to polar. Okay, so if we had, let's see, our polar conversions. If we had an x squared plus a y squared, we can convert that to r squared. And if we had an x, we convert that to r cosine. And if we had a y, we would convert that to r sine. Okay, so everywhere we see x's, we're going to write r cosines. Everywhere we see y's, we're going to write r sines. And if we see an x squared plus y squared, we're going to write r squared. So let's start with b. That one's really easy. X squared plus y squared, we know this is replaced with r squared. And it still equals 7. So then the last step to simplify is to root both sides. So we get an equation r equals the square root of 7. A nice circle centered at the origin with a radius of root 7. Okay, nice and easy. Now let's come over here and squeeze some more lemons. Now we have x squared equals 12. So the conversion is still the same. I have an x, so I'm going to write r cosine theta in terms of x. And replace x with that, and I'm still squaring that, and that's still equal to 12. Okay, so now we have to simplify and get r by itself. So I'm going to square root both sides. Okay, this is the quickest way to get rid of the square rather than distributing, even though that would also be appropriate. So r times the cosine of theta is equal to root 12. So now we're going to divide both sides by cosine. So rather than having cosine in the denominator, I'm going to change 1 over cosine and replace it with the secant. So this is going to be root 12 times the secant of theta. Okay, that is how we get a polar graph of a rectangular x squared equals 12. Okay, which is, of course, a vertical line. So there are your two problems. One is a circle and one is a straight line.